you doing, Scott? Are you interviewing before you're interviewing before the show?
I'm just setting up.
OpenVZ is, real basics of it, but it is an advanced topic. There's going to be, stuff might go over your head. And my demonstration is going to be entirely command line stuff. And so I'm going to be typing commands, you can see little text results, stuff like that, which, I tell people I'm a server guy. I find that to be just riveting stuff, but not everyone is really excited about those kind of things. So, there's no GUI with OpenVZ. In fact, there might be. I think I've heard of a project of a guy creating a front end, a graphical front end for configuring and working with OpenVZ. But I haven't actually tried that. Get started here. A little bit, just briefly about myself. John Blandford, I'm giving a presentation here. I'm not a virtualization expert. I'm actually just a general system administrator. And working with Unix-based systems since the mid-'80s, and really with Linux systems beginning in the early to mid-'90s, and sort of full-time Linux open source specialist as much as I could, as much as I could make money doing it, since around '98. My experience with virtualization, as I said, I'm not a virtualization expert. I don't have any connection with the OpenVZ project itself. I'm just a user. And all the software I like working with does what I need. My previous experience, my very first stuff that I did in virtualization with was VMware, which I used years ago to make the transition from on my desktop at home from Windows to Linux. I was dual booting for a while, and then I had one program really that was tying me to Windows. It was an online bill paying program written in Visual Basic, and at least once a month I had to have boot up Windows and run that program and stuff like that. So to make that final break from Windows at home, I used VMware, and it would run Windows inside that, and that allowed me to finally get rid of the dual boot option and just have one operating system. VMware, when I used it, this was a few years ago. I think it was 99, something like that, 2000 or something like that. That I made the migration. Worked, but it was really slow. But it did what I needed to do and got me across the hump. I didn't do a lot of virtualization stuff after that until about 2005. I had heard a lot about virtualization, and it's really big in the industry. And I would go to conferences and people would keep talking about virtualization this and virtualization that. The new data center is the key phrase that we're talking about here. Virtualization is going to change the way we do servers in the data center. But I was skeptical because I've seen a lot of marketing bullshit over the years. So I don't always listen to what I hear at the conferences. But I heard about this thing called Zen, which is an open source virtualization system, an open source hypervisor, which is one of the types of virtualization systems. And I tested it out in the laboratory, in my lab, and I was very impressed. It did a really good job. It's very stable, very high performance, not as high as OpenVZ in some cases, but very high performance. And it has one really killer feature that really opened my eyes as to what virtualization can do for you. And I started taking it more seriously. And that's a feature in it that Zen calls live migration. So you can have a virtual server running on one particular physical piece of hardware and live migrate it onto other hardware. You can live migrate it onto another piece of hardware while the server continues to run and while people can continue to interact and do all their work on that server. And the downtime, there is a little bit of downtime in doing that, but it's measured in milliseconds, tens or hundreds of milliseconds of downtime to move that across. So that's really impressive. I tried it out and tried to make it fail and put load on the system and do that kind of stuff, and I was never able to make it fail.
How does it keep it consistent? I'm just curious.
How does it keep it consistent? Well, we have to ask the Zen guys about that. They have a process where the file system has to be network-based. So the files they're getting from some network source.
I got it now.
And then the rest of it is just migrating the memory image from one place to the other. They have a neat little system of iterative copying that they do. And they don't actually shut everything down until the very last second, until they're not getting enough new stuff, or not getting enough mileage out of copies, and they shut it down for a short amount. But that, as I said, that really impressed me. It worked well. I could not make it fail when I worked with it. For fun, this is how server guys have fun. I would put it under load and run a patchy benchmark test against it, just to give a real load to the virtual server. And then I would sort of flop it back and forth like ping pong. Ping pong, ping pong. The virtual server would move between two different hardware, and I could never make it fail, and I could never really see any effect on the benchmarking results by moving the server back and forth between two different physical boxes as it was running. So that impressed me. I wasn't ready to start using Zen at that point. I didn't put it in the production environment. I didn't have a particular project internally that I wanted to use it for at that point. And at that point, this was in 2005, the tool chain of working with it was really immature. It was difficult. I couldn't imagine turning it over to a client and saying, here, I set it up, now you take care of it at that point. It wasn't, you had to have enough background knowledge to work with it to make it actually get anything. But I was impressed. I continue to look at virtualization systems, and the three things that I was looking for that OpenVZ eventually solved for me were those ones I've listed. A lightweight platform from custom servers. I'm co-owner of a small hosting company called Planetary Data Systems. And right now we offer shared hosting on servers, or you can co-locate your own hardware with us, but nothing in between. And we particularly had issues with customers that wanted very customized versions of software and stuff like that. All our shared hosting platforms are all PHP 4 and MySQL 4. And of course, there's always some customers that want PHP 5 and MySQL 5. I have to say, well, you want to buy your own box? And most of them didn't want to buy their own box to do that kind of stuff. So I was looking for some way to easily create custom servers for customers for particular needs, and not necessarily have to dedicate a whole physical piece of hardware to a particular customer to do that. Testing new server software, that's something presently that have been doing by having multiple hard drives and a test machine. So I have a test machine with a removable hard drive caddy, and I have a bunch of big stack of hard drives with various configurations of different operating systems and software and stuff like that. And when I need to test or work on a problem for a customer, I would take the hard drive, put it in the physical server, boot it up. When I was finished, we'd bring it down, take the hard drive out, which worked. But I was looking for something a little, a lot more lightweight than keeping stacks of hard drives relating to different customers and things like that. And finally, I've been doing a bit of web development these days, so looking for an ability to create custom development servers on a project basis. In other words, if I'm working with a particular customer, I could set up software that they're going to need for their project, perhaps even turn over the root password to this server to the people I'm working with, let them knock themselves out for a couple months, and then be able to destroy it and get rid of it without having invested, again, a physical server to do that kind of work. So those were the things that I was looking for, particularly the itch that I was trying to scratch with virtualization. And I've begun using OpenVZ to satisfy those needs, which brings up the question, if I didn't use Zen and I am using OpenVZ, how is OpenVZ different, and why did I decide to use that rather than Zen? Well, it turns out to be actually a more difficult topic than you might imagine to explain. But what I want to do is put OpenVZ in context to the rest of the virtualization world. And it turns out the virtualization world is kind of complex. It's not a simple universe to talk about. Virtualization is really hot in the computer industry in general. That's led to a lot of products being produced, a lot of technologies, there's a lot of diversity. in that. And more recently, virtualization has become real hot in the Linux and open source world too. For years, there were virtualization projects in the open source world, but they were kind of sleepy backwaters. They weren't front burner kind of projects. More recently, virtualization has become a real front burner project. And you see a lot of the big name kernel hackers and stuff like that are involved in doing virtualization work. So that's led to a lot of, to add on to the commercial stuff, that's added on a lot of open source projects now that do virtualization. So there's many different ways of doing virtualization. There's a lot of diversity in it. And just an example, I'm going to pop out of here and go real quickly over to my web browser. The first example, sort of showing you how virtualization has become hot in the open source and Linux area, is I have a little talk description from Linux Conf Australia that was done in January. And one of the talks was by 4 different virtualization programmers talking about virtualization topics. And they were talking about hypervisors, which is a type of virtualization system. And the title of the talk was Writing an x86 Hypervisor. All the cool kids are doing it. And that really sort of picks up the excitement these days in the open source world. All the cool kids are actually doing virtualization kind of stuff. I love the first line there. It says virtualization is not just a way to extract money from venture capitalists. And then the other example here, just to give you an idea of the complexity or diversity of approaches in the virtualization world. This is a great page at Wikipedia. It's a big table where each row is a particular virtualization technology or product. And these are not just open source or Linux ones, these are just in general. But the thing I wanted to show you is if you start scrolling down here, this list is very long. Lots of projects.
Pretty thorough.
Very thorough. Whoever did this at Wikipedia are the people that did it. Really made a thing. But the list keeps going and going. I'm still trying to get down to the bottom of the list, or finding the bottom of the list for spreadsheets. So there's a lot of diversity in there. I'm not going to attempt to explain how each of those is different, how they relate to each other, and all this kind of stuff. That would be a great presentation. I would love to go to that presentation. But the key issue I think for us in here is how is OpenVZ different? How does it compare? How does it fit into that universe of all that diversity and stuff like that? So that's what I'm going to focus on here. And instead of trying to get into all the complexities, I'm going to go the opposite way. I'm going to do a radical simplification of it and just look at 2 broad approaches. I'm just going to classify virtualization into 2 very broad categories here. And these are my categories. They're not commonly used in these terms. I think it's a useful way. I base this distinction on some ideas in a paper from the Linux vServer project. It was very helpful for me in understanding how this particular approach that OpenVZ uses compares to all the others. So the 2 basic things there are categories that I like to talk about are hardware virtualization and operating system virtualization. OpenVZ fits into the operating system virtualization category. But first of all, hardware virtualization. This is the most common approach to doing virtualization. If you've had any experience with doing virtualization, you probably did what I would classify as a hardware-based or hardware-oriented approach. So projects like VMware, Xen that I talked about, QEMU is a great open source emulator that written by a French Uber hacker named Fabrice Ballard. Very nicely done. And KVM is sort of a big, hot, darling project of the kernel people. That's adding virtualization capabilities directly to the Linux kernel. And essentially turns the Linux kernel into a hypervisor itself. The kernel guys say, oh, we don't need Xen. We can hypervisor stuff like that. Now, what unifies all these different projects and unifies what I call hardware virtualization is that the unit of virtualization is hardware. So when you read about it or look at the documentation on it, they'll talk about virtualizing CPUs, hard drives, network cards, right? So the unit of virtualization is actually physical hardware. For example, QEMU provides a virtual CPU, and inside QEMU, even if you're running it on, say, an Intel architecture machine, you can boot up QEMU and run code for other architecture. You can run code that's compiled for a PowerPC or other CPUs that QEMU emulates. So it actually emulates or provides a virtual CPU. Same way with QEMU provides a virtual hard drive. So inside the emulator, you actually have access to a hard drive that you can F-disk and install Grub on and just treat like a normal hard disk. Although actually it's just a big file in the underlying operating system, underlying host operating system. So the unit of virtualization for what I call hardware virtualization is hardware. That's why I call it hardware virtualization. Operating system virtualization is a little different, or very different. The unit of virtualization for operating system approaches are operating system constructs. They're not hardware, they're operating system resources. So they're things like processes, files, file systems, users, other resources that the operating system creates and manages. So notice, big difference here is what I'm trying to get at. What are we talking about here? CPUs, hard drives, network cards. What are we talking over here? Processes, file system, users. So we've made a different leap here. We're in a different world of doing virtualization. We're virtualizing fundamentally different things in this case. Examples of operating system virtualization, OpenVZ, of course. Linux vServer is a very similar kind of project to OpenVZ. OpenVZ is sort of a commercial open source provided by a particular company. Linux vServer seems to be more of a community-based development model. And another product outside the Linux world would be Solaris containers and zones, which is essentially the same stuff. Yeah.
Would you consider BSD jails part of this, or is that really kind of?
I think so. I don't know enough about BSD jails to put it on there. And in fact, I did have BSD jails on.
It is frequently grouped in that category, yeah.
Yeah, I had BSD jails on here the first time, but it was too far down on the slide, so I took it out. So, yeah, I think it is the same stuff, but I haven't actually used that. Well, the central concept of operating system virtualization is the idea of a resource container. And this is a little difficult to describe. I'm going to do my best here. It'll hopefully make a little bit more sense when we get to do some practical work with OpenVZ. But the idea of a resource container is an additional piece of information, additional piece of sort of classification information that we're going to add into all operating system resources. So, for example, processes that run on an existing system or an unmodified operating system, once you start a process up, all the processes are just running on that system. There's no differentiation, nothing different about them. With the idea of a container, we associate a container ID with each of those processes. So now we've got an additional piece of information. We can say that this process is running associated with this container, and this process is running associated with a different container, and so on. A good analogy, I think, is like files on a hard drive. So if you took all your files and just dumped them into one big directory and didn't do any differentiation, any subdirectories like that, that would be like a regular operating system. When we add in the idea of containers, it's sort of analogous to like creating subdirectories. And we're going to put all our files into a different subdirectory and keep them separate that way. In this case, we're not just filing files, but we're filing in these subdirectories, processes, users, all those kind of operating system constructs. So we're associating an additional piece of information so that we can tell one process from another process as opposed, or with which container they're associated with. Once you have the idea of containers, there's two things you can do with them, or it's more than two things, but two main things you can do with them. One is resource isolation. once you have the idea that there's these containers, you can keep the containers isolated from each other. So for example, a process running in one container can't directly access or talk to a process in a different container. Right? As far as that containers or that process is concerned, that other process doesn't exist. Right? We're going to isolate it from each other. Same way, a process running in one container can't access files that belong to a different container, and so on. Right? So we're going to provide that isolation between the resources, between the containers. Resource management is just my way of saying, keeping track of the usage of resources per container. And generally in OpenVZ, you are able to set either guarantees or minimums depending on the different usage of different terms depending on which resource you're talking about. So either you provide a guarantee, minimum, or a limit or maximum for things. So for example, the classic example of this would be CPU usage. Right? You could say this container has a guarantee of a certain amount of CPU power. So maybe it has a guarantee of 10% of the CPU. And it's guaranteed to always have that, no matter what the other containers are doing. And the same way you could set a maximum. You could say, well, this container has at least 10% of the CPU resource, but it can never have more than 20%. Right? So that's a way you can use the container idea to manage the usage of resources between containers. And the whole idea with containers and associated information is to give the illusion, have a single operating system, but give the illusion that there are multiple copies of that operating system running. So a user of one particular virtual server has the illusion that they have their own little server all by themselves. They only see their processes, they only see their files, they can only interact with their users and so on. But really, there's just one operating system running, and these are just different processes and files in that basic underlying operating system. This gives the illusion of multiple copies of itself. The advantage of this process or approach, the big one for me is it's very lightweight to use. There's just one operating system kernel running, so you're not using a lot of CPU or memory resources to run multiple kernels on the same piece of hardware. There's just one kernel running. Resources for one. Unlike most or many hardware-based approaches, there's no emulation overhead involved in OpenVZ because we're not emulating any hardware. In fact, a lot of the diversity and complexity in the hardware-based side involves this issue. How do we do emulate? How do we avoid emulating if possible, and those kind of issues. So in this case, we're just skipping that whole issue entirely. We're not doing the emulation. But the big thing that really sold it for me doing this kind of approach was that putting a new virtual server onto the system is just a trivial thing. All you're doing is just adding a few files, starting up a few processes, creating a configuration file, or whatever. But it's really lightweight, and the process of creating a new server, and I'll show you here in a couple minutes, you can create a new server very quickly. I'm a slow typer and all that kind of stuff, so maybe it'll take me 2 or 3 minutes to create a new virtual server. Get scripted, and it would take 60 seconds or something like that to create a new virtual server. And the same way, getting rid of a virtual server is a single command. I did it before you guys came in. I had a virtual server on there, and I destroyed it with one command. It took about 15 seconds, and the virtual server was gone. That really beats a lot of the other virtualization systems, and sure as hell beats physical hardware. Right? It's the difference between 2 minutes and calling out someplace and waiting 2 weeks for them to deliver a server, and then taking it down to the data center and figuring out how the rails connect to it. And I always seem to have the problem. I figured out how the rails go on. I put them on. I take it out to the data center. And I go into put it in there, and it's like, oh, they're backwards. Oh, my God. So I take it back out, and I put the rails back on. So I'm a software guy. I like creating servers virtually much more than I do creating physical servers. The other big advantage for this kind of approach, it's less interesting to me, but it is interesting to a lot of people, particularly that do mass hosting and stuff like that, is that it's possible to do extreme virtual private server density using this, because you make use of the fact that most people's servers aren't in action at all times. So maybe you can put 50, 100, 200 servers on a particular piece of hardware, and maybe 10 or 20 of them will be active at any particular point. So you get that statistical multiplexing advantage. But this estimate that I've got for you, 50 to 200 servers per gig on a modern dual CPU system, it's a little bogus because obviously it depends a lot on how much load each of those virtual servers will have to do. But I'm just basing that on wiki entries and million-less postings that people have claimed. This is what I get 100 virtual servers doing that stuff. So just to give you an idea of the order of magnitude, these are figures that I've seen for OpenVZ. Disadvantages. Well, I said we're only running one kernel, and that's an advantage, but it's also a disadvantage. Essentially, you're only running the one kernel. There's only really one operating system running. Right? You're making it appear like there are multiple copies of that operating system, but there's really only one running. So every virtual private server that you create is going to be a flavor of the same underlying operating system. So to answer the inevitable question, it does mean that if you have, if you're running a Linux server, you're using something like OpenVZ, no, you cannot run Windows virtually that way. Right? If you're running Linux, every virtual server will be some version of Linux. If you're running, Solaris containers, wherever it is, every virtual server is a version of Solaris, right? It's just you're giving the illusion of virtual servers, but there really only is one server involved there. In practice, OpenVZ allows you to use most distributions of Linux will work with OpenVZ. So the virtual servers don't have to be the same distribution as the underlying base operating system. Any distribution that will work with the OpenVZ kernel should work inside a virtual environment. Yes?
So when you were talking about having the same kernel, does that even mean that you can't, you have a Red Hat box with the 2.6 point whatever kernel, all the guests have to be the same exact kernel version? Right?
There's only one kernel. Right. There's only one kernel running, so the answer would be yes.
So the only thing different between the machines could be packages or...
Right.
It can be different distributions.
Yeah.
It can be?
Yes.
As long as the kernel version is exactly
right.
the same. Okay.
Well, as long as whatever hardware comes with that distribution will run with the OpenVZ kernel, then no problem.
Okay.
Yes.
But then also, if one of the guest OSs causes a crash, then all the other guest OSs will crash too, right?
That's right. That's right. There's less isolation between the virtual systems. That's right. Yeah, something like Zen, you can crash the OS in one virtual server and it doesn't have any effect on the others. So yeah, I guess one of the disadvantages I could put in here the next time I do this would be to say there's less isolation between virtual systems in this way. Because there aren't really separate systems. There's just one system that gives the illusion of multiple systems.
So this is more like application for testing.
It can be used for testing. That's one of the things that I like to use it for. People sell, virtual servers using this technology. People use it for websites and databases and stuff like that. So it can be used in production environment. The commercial version, well, I'll go to the next slide here. OpenVZ is a container-based approach for Linux. It's commercial open source, i.e. it has a commercial company that backs it. The company is called SWSoft in Russia. They produce a commercial version of OpenVZ called Virtuoso. And I thought of that because Virtuoso is widely used in the hosting industry as a solution. You buy those ultra-cheap virtual private servers. A lot of them are going to be Virtuoso that's creating them. OpenVZ there's two parts to it. There's the kernel component, and all the fancy stuff, the real virtualization stuff, goes on in the kernel. And then there's a series of tools that allows you to work with the capabilities that are built into the kernel. that part, the kernel and the tool chain, are all GPL and freely available. Virtuoso adds some additional stuff, support, enhancement, management tools, and other stuff. I'm not really familiar with what Virtuoso does, but you can check out the website if you're interested in the commercial version of it. So that's pretty much what I wanted to talk about for the beginning. The rest I would like to do some practical stuff, like working with OpenVZ. Oh, my machine. So what I've got is I've got a problem is I have difficulty typing and talking at the same time. So sometimes you'll have these little gaps in my discussion while I type here. Just for some reason, I have difficulty with that.
Up arrow, Control A.
So what I've got is a server. It's actually at a data center here in town called Firewood, where I've installed OpenVZ, and I'm going to use that for the test purposes here. The server is a 2U system with it's got 2 gigs of memory, dual CPUs. Let's see, we run till 250. 2 CPUs. It's got a single mirrored 36 gig, or it appears to the operating system as a single 36 gig SCSI drive, but it's 2 SCSI drives mirrored together with some sort of RAID stuff. I forget which one it is. And what I've installed on there is a copy of CentOS 4.4. And first thing about OpenVZ is it tends to be a little Red Hat centric. And if you go to the website and look at the website, the OpenVZ website, and look at the how-tos and stuff like that, most of the examples and most of the packages and stuff like that they make available all assume that you're running some sort of Red Hat derivative. So either Red Hat Enterprise Linux or CentOS, which is a clone of Red Hat Enterprise Linux, or Fedora, first version of Fedora supported. Now you can use other versions of Linux as your base operating system, but it's going to take a little bit more work on your part. And there is some instructions that people have done it. You can see in the wiki there's instructions about how to do this. But the easy approach is to use some Red Hat based system. Not real quick. Some Red Hat based system. So what I did is I installed CentOS 4.4 as this. It's a pretty basic install. I tried to keep the amount of packages down. OpenVZ suggests that you make the base system as lean and mean as possible. You don't want to add a lot of stuff to it that you have to maintain. And they suggest a particular partitioning strategy. So if I do this, I've got a root partition that is where the main operating system is installed and all its files are in a big root partition. And there's a separate /VZ partition. And that's where all the OpenVZ files and all the files associated with virtual servers are going to be kept somewhere below there. They like their directory, their VZ directory, to be a separate partition because it helps their quota system work a little better. File system quota. Excuse me. So I'm not going to actually show an installation like that. I'll just briefly describe it. It's well documented at the OpenVZ site. There's 2 components to setting up OpenVZ. It was actually pretty quick. 2 components are the kernel and the tool chain. Now the kernel stuff, I downloaded a precompiled kernel And they have ones available for CentOS for Enterprise Linux and various versions of Fedora. I think they actually have SUSE available.
Mandrake Corporate Edition, not that I use it, but it includes OpenVZ support, and supposedly the new SUSE that's coming out is going to support that too, as part of it with the Zen as well.
Okay.
So far as installing it goes, I just want to mention, if you don't mind, that you can just get the OpenVZ repo file, and you can just use Yum to install everything.
Oh, which is exactly what I did. Yeah, when I say installing the stuff, I didn't mean downloading by hand, which you can do, but the instructions there give you a way to get the repo file, and I just used Yum. So my installation was Yum install kernel dash, whatever, something like that, and that was it. It was really quick. There are some recommended configuration changes that they suggest you do, and they're documented well and went real quick. So once I had the kernel installed, I just set up Grub to boot it, and we're now running a OpenVZ version of the kernel. Now, if you didn't want to download one of their pre-compiled versions, OpenVZ is also available as a big patch to the standard Linux kernel. So you could, if you wanted, and you enjoy your own kernels, you could download a basic kernel source, patch it with OpenVZ stuff, and then compile it and have your own version of OpenVZ kernel. But once you've got a kernel installed and it's running, that's the main stuff, and that really was very quick to do. Now there's a series of tools that work with the capabilities there, and again I used Yum to download them, and again it took 2 minutes to do it, and I was up and away. So at least in using CentOS, the installation part of it was trivial. Went without any particular problems at all. From reading the stuff in the wiki and the mail and stuff like that, people use other base operating systems, and of course it takes a lot more elbow grease to make those work together, do it all by hand, but it's quite possible. The technology is not limited to Red Hat-based systems. Well, I thought I'd start real quick by just starting up a pre-existing virtual server just to show you, that it actually does run, and just do some really basic stuff with it. This is the VZ directory structure, and probably the most important one for our purposes right now is a subdirectory of that called private. And this is where, if we cd into private, this is where the file systems for each of the virtual servers is kept. In OpenVZ, everyone see that? In OpenVZ, the virtual servers are known by a number name. So it could be any arbitrary integer that refers to them. I'm using the last 3 digits of the IP address that I've assigned to the virtual server. It just makes it easier for me to remember one from the other. But they could be numbered just, 1, 2, 3, whatever.
For some reason, they recommend above 100.
Do they really? I didn't see that. Okay. Well, any number you want, it's an integer that's above 100. Well, it should work. So I'm going to work with this 177 server there, which is a copy of CentOS that I installed. It's already ready to go, so we'll just go ahead and boot it up and see how it works. So to boot it up, we say vzctl, and this is sort of the base command that you're going to see a lot, vz control. And it takes a whole bunch of different options for doing various things with OpenVZ. In this case, I'm going to say vz control start 177. So I've pre-configured this. It's all ready to go. I've configured it multiple times. And it tells us a few things here. I've already preset that its host name is lummy.plans.com. Here's the IP address that I've given it. And CPU units of 100 is the guarantee, or 1,000 is the guarantee for this machine, which is really low. I think this machine supports 400,000 CPU units or something like that. So that server is now running. If we use the command vzlist, it'll show us all the servers that are currently running. And we have one down here, server number 177, numproc. There's 27 processes associated with that virtual server. It's running, type the address and source name and so on. Now, yeah.
So you said the CPU, and this is like a nice value of rules?
No. It's an arbitrary number that OpenVZ uses to control the resources between CPUs. And if I remember correctly, so yeah, this node, it calculates that this node is able to do about 400,000 CPU units. And I've guaranteed that this particular virtual server has at least 1,000 of that. So I've given it like 1/400th of the CPU. Now, by default, it can burst up to 100% of the CPU usage. So this is just a floor, a guarantee that it'll have at least 1,000. But at present, the way it's configured, it could actually drop up and do 100% of the CPU total CPU access. I'll show you if we have time before we don't run out of time. The last thing I can show you is being able to set a limit so you can also control how much CPU that is. But actually, I think they're just an arbitrary number. I'm not sure the internals of that works, but it's definitely not nice. Although it's sort of similar. Okay. So we've got this 177 server running. If you've got something like Secure Shell running inside it, you can actually Secure Shell into it, and I can show you that at some point. But also, if you're the administrator of the base system, you can actually go right in to the virtual server. And again, we're going to use VZ control to do that. And now, ta-da! I know it's not very exciting, but we're actually now inside the the virtual server, the 177 virtual server. Notice our prompt turned to Lummy, which is the host name of this server, to show you that we actually are in a virtual environment here. If I do PSAX, notice we've only got a few processes running here. We've got a copy of the init. We've got some Apache running, send mail, and a few things. If I exit out of here and do PS in here, you notice that the base system actually has a lot more processes in it. So what we're seeing inside the virtual server are just those processes that are associated with this particular container. Now, when we're doing the PS in here, this is a mix of processes that are associated with the base system, as well as processes that are associated with various containers. Well, in this case, we've just got one container running. So to show you that, if we look here, we've got a copy of sendmail here, and we've got a copy of sendmail down here. So there's actually two copies of sendmail, yes.
PS tree, I think, is really good to visualize this.
PS tree.
Give it the -NUP flag and pipe it to less. NUP. I know you're typing challenged.
Yes, I am. You notice that?
So there's your init 1 at the top. It's really the first process. The process IDs are virtualized. So if you scroll down, you'll eventually see another init process. And from the host machine, you can't have two processes with number 1. There's the second init process, and you can see what processes fall underneath it. And if you had multiples, you'd see another init and its processes, and another init and its processes.
That's a very good way to visualize it. Thanks for showing that. So yeah, these are the processes that are associated with the 177 virtual server.
Now, if you were to compare the process numbers from the host versus the client, they're completely different because they're virtualized.
In fact, we can look at that right here. Let's do that. There's a nice little capability or command called VZPID that takes as an argument one of the PID numbers, and it'll tell you what container, what virtual server that process is associated with. So if I grab like this one right here, tells me that that copy of SendMail, which is 28909, is associated with the 177 server. And if we do, if we look at the SendMail, which is the same process inside here, its PID number is 29933. So proving what he said there, that we're virtualizing the process listed inside the virtual server. And if we look at the file system, it will be completely different inside the virtual server compared to what's in the base system. Different numbers and different processes shown there. Same sort of thing with excuse me, with file system. If we do a DF inside the virtual server, what we see, you can see down at the bottom here, is a 2 gig file system available for us inside. If we exit out, up here, base system, we got 26 gigs, but inside the virtual system, we're just seeing the 2 gigs that we are associated with this particular container. If we look at product mounts, what's actually happening is this. So the private directories, or the subdirectory of private being 177, is actually getting mounted on VZ root 177 using this special file system called SimFS. And SimFS is a file system that's provided by OpenVZ. It's one of the basic components of OpenVZ. I don't know the underlying structure of how the code works, but I'm assuming that this SimFS is the virtual file system that's doing all the stuff of what you see inside the virtual server. It's something that's making it look like a smaller disk and enforces the quotas and all that kind of stuff. So questions about that basic idea? Okay. Well, what I want to show next is just how quickly and easily you can create a new server. So there's two components to creating a new server. One is you're going to create a subdirectory of private, and then you're going to take a bunch of files that you're going to use as your root file system for that virtual server and drop it into that subdirectory. And then you're going to create a configuration file that specifies how that virtual server is going to work and so on. So VZ control will do all that for you. If we take a look over here, into the template cache directory. So this is VZ template cache. I've got installed a few of what OpenVZ refers to as template cache files. And essentially what these are tar archives, compressed tar archives of all the files that you want to go into the root file system of a virtual server. So VZ control, when we create a new server, is just going to create a directory, untar this stuff in there, and it'll run a few scripts to configure things and stuff like that. But it's really a very simple process of what it's doing. To get these template cache files, there's 3 ways you can do it. OpenVZ itself supports, for some operating systems or some versions of Linux, something they call cache metadata or template metadata, which is essentially enough information that allows some of the tools to actually create these files for you on the fly. So it'll go out and get the latest versions of all the packages for a particular operating system and install them and put them all together and create this template cache for you, fresh template cache. I haven't actually tried that process. It seems like there's just a few versions of Linux that are fully supported with that cache metadata. Do you know which ones?
CentOS and Fedora.
CentOS and Fedora. So I haven't actually tried that. It looks like it would be very slick when it works, but it didn't support the things I wanted to do for a lot of stuff. The other approach is to just download a pre-created template cache. There's a bunch of them available through the OpenVZ site. And in fact, this one right here, or I think these two CentOS ones are both ones I just downloaded, and that was easy enough. It means that the configuration here is a little different than what I would want, essentially, in some cases. And the files are not the latest. They have all the latest security updates, but it's easy to update that stuff. And the final way to create one of these, or get one of these caches is just to create it for yourself, which is what I've done for like these two here, the Debian and the Ubuntu one. I just made on my own. And it's really, there's not that lot different between a version of Debian or Ubuntu without OpenVZ and with OpenVZ. So we're just installing it into a directory and I use that and tar up the files and do a few things to it. I won't show that process, but we'll just start from the already pre-created template cache. So if we're going to create a new server, I'm going to create a new one called 180. Now I'm going to tell it which OS template cache file to use. They're named by the beginning here, everything except the dot. Whoops. Oh. Everything except the .targz part. Okay. So here I've got it, and we'll set it out. So what it's doing right now, it's creating that subdirectory. I named it 180, and now it's just untarring those files in there. And this will take a little bit of time to do, but again, compare this to Dowdle. Okay, so we've done. The basic creation is done. We can do a little bit of configuration to it. First of all, I'll set the IP address for this one. Oops. And all these configuration commands I'm giving for are going to be the same sort of format. It's basic control set, the virtual ID number, and then some thing that we're setting, and then at the end, --save. If you don't add the --save stuff, it just sort of temporarily makes that change, but doesn't update your configuration file. But if you put --save, it will actually save it into the configuration file for future versions. So we'll put that parameter in there. I'll add in a host name. There's a few other things you can have for our purposes. That's fine. And let's go ahead and start it up. So now we're inside that new virtual server that we just created. So the process is, we've got a few more steps to go, but it's a really quick process compared to anything else that I've seen. And that was when I did that, I went, oh, this might be something I can use. I like quick and easy. Yes?
Do you know if it uses like a emulated MAC address on the network, or is it actually using your physical MAC address so that you always have to, like, what I was thinking is, can you use DHCP to assign IPs to your host?
There are two types of network interfaces that OpenVZ supports. One is, the first one is the one that's used by default. And it's my understanding that all of those use the same MAC address. They're basically virtual interfaces, if you want to think of it that way. And the second one, you make up your own MAC address. Which is what almost all the other virtualization methods that have separate MAC addresses allow you to do. Right. Although, oddly enough, some virtualization products have actually registered the first three numbers of the MAC address with their own company. You know how hardware vendors, the first three identify the hardware? Now, the first three can also identify a software vendor as well for virtualization.
Can you type if config on this and then if config on the parent?
In the default one, you can give someone root access to their VPS and they cannot change the network configuration whatsoever. So you keep them from messing up your network. If they need that, then you can use that secondary type of network interface, and you can use if config, and they can change things, and they could actually sniff packets if they wanted to. So that's why you don't want to use that unless you absolutely need to.
I guess kind of voice address, so that one's just eliminated.
Yeah, well, it's a separate IP address. It's just got the same MAC address. From the outside world, doesn't care. Doesn't know any difference.
Right, in fact, that was the next thing I was going to show is you can go from the outside world quite easily. I just set the root password in here, and I'm just checking to see if Secure Shell has started up. Probably complaining here about the last time.
You got a 1.8 instead of a 180 in there.
Oh, over here?
Yeah, in your host file that you were just looking at.
Oh,
By the name says VPS 1.8.
Oh, 1.8, okay. Let's just use that for right now. I'm trying to fix it. Ignore the fact the last time I did this demonstration. Where did I get that password from? There we go. Okay, so we're now secure shelled into it, and I used, although it was a little unusual because I had the stuff in my host file because of the DNS issue I was having for a while. I used the regular outside address that we assigned to it, so from the exterior world, it's no different. And in fact, we should be able to go over here. And access the web server that's running inside that, so that's the default page in the CentOS install. That's inside there. For the outside world, it looks like a normal server. All of the networking inside is working. Let's exit out here and show one more thing. So there's also a series of tools that OpenVZ gives you as the administrator of the base system to do various administrative tasks inside the virtual server. I'm not going to show all of those, but one that's to show you the general idea of it. There's one called VZ Yum. It's like the Yum command, which works with does package management stuff in the Red Hat environment. But VZ Yum allows you to do it on behalf of one of the virtual servers. So I'm going to use VZ Yum here to actually install some software into one of the virtual servers. Yes.
You have an adapter. I think your laptop is to run a battery. So the indicator in the bottom. They were like moving now 671.
Oh, you're right. We're down almost to the bottom now. Okay. Let me start this going here. This will take a second.
It started to shut down. It's okay. Yeah, it's shut down.
The template cache that I used to create the 180 thing did not have Yum installed in the root file system, or the root images that were created. So I'm going to actually use VZYum to install Yum into the virtual system. And then once we've done that, within the virtual system, I can use Yum to add and remove software inside there. So we'll do that.
Yes.
So that quickly, I just installed Yum into the virtual system. And now if you notice inside UPS 180, we do have Yum available, and I can actually use it to install some files here.
Did you set DNS inside your VPS so it knows how to resolve names?
Well, we'll see here in a second. I don't think
Yeah.
I did. I'm worried about that.
Are you on the right machine?
Yeah, the Yogi is my laptop. I was logging as root, so maybe the path was somehow incorrect. Oh, yeah, no one may tell me. I'm on the laptop. You're right. Jesus Christ. Okay.
Too many virtual machines, it's confusing.
Well,
Yeah.
particularly when I was thinking about doing this, something with like colors and things like that, I recognize right away when I'm one machine to the other. Okay, new sack, going in the right place. Well, we know that. We know what it is. Oh, you know what happened? I gotta fix this. Oh, yeah, we do that one. Right, thank you. Okay. Okay, look a little better if I give it the right number. Okay, so now we got proper DNS in there. Sorry for a little detour here. Now let's see, where was I in my demonstration here?
Yum, install
Yum.
MySQL server.
That's right, thank you. So now that we've installed Yum inside the virtual machine, we actually do have the capability of installing software. And what we're going to be doing is installing into that, /vz/private/180 subdirectory tree, directory tree.
Yes or no?
Okay, so whenever we actually did it, or we're going to do it here. And I installed a specific set of software because in a second here, if we have time to get to it, I'll try and start up some stuff and it won't work. And I use that hopefully as a nice way of pointing out to people about resource limitations. And one of the challenges I had when I first working with OpenVZ is that the default configuration they use to create new virtual servers is very lean. It's very restrictive on the amount of resources that are associated with each new container. And I was easily able to exceed the resource limitations of containers, which would cause various software to just sort of fail with very strange and unusual error messages I've never seen before. We're still going.
Right.
We're not dead yet. We're still going. So the next topic here is sort of resource utilization issues like that. We'll see how far we can get on this. First of all, the real simple stuff, if we look at df-h inside the virtual server, we have 1 gig associated with 180 server. Let's see how we can change that. If I go out here and go into etc vzconf, this is where the configuration files are kept that configure each of the virtual servers. And so I said I'll find about the default configuration here. That's to be light.conf. You can specify when you create a virtual server a different base configuration, but by default, this one is set is used. If we look at the 180conf, you'll see all the various resources that you can set inside the virtual server. And for the disk stuff, we'll come down to the disk section here. I'm going to change the disk space here. And that should have the effect of actually increasing the virtual disk size that we see inside the virtual server. So just to show you the general approach you can do to change resources, let's go ahead and try that.
And I would like to interject, one thing that's really cool is all of those are dynamically changeable. You can issue a command from the host machine and change any of the running parameters on a running VPS dynamically. So they want more disk space, or plop, you don't even have to restart the VPS, it's bigger. They need to be able to run more processes or have more memory, plop. That save just saves it to the config file. If you don't use the save like he said, it just changes it in the machine and it doesn't write it to the config. So usually you want the -- save on the end, but you don't have to have it.
So what I'm going to do, I'm setting changing resources as it says on the fly or saving them. It's generally the same sort of syntax. VZ control set the virtual ID that we're setting it on. And then minus, is usually the same parameter name here, except lowercase for it. So minus disk space, and then we're going to set it to something here. And just for quick and dirty here, I'm going to approximately double these numbers here. So this would be about 208 and 4 zeros. I'll make that one about 230.
You got 5
Was
zeros.
I 5 zeros? Now that, as he said, it's dynamic. It took effect immediately. If we look at the configuration file, you'll also see that the disk space for future boots has also been changed. If we go back inside the 180 server,
It actually had a
You had a failure
Oh, did
because your
it?
hard limit is smaller than your soft limit.
well, let's count those zeros.
You need 5 zeros.
You-
1, 2,
you
3,
did
0.
23 instead of 2.
One more zero. There you go.
Uh,
Yeah, that's right.
All
Yeah,
right.
that's better. It's 2, 3, 0 plus 1 zero. Not 2, 3 plus 4 zeros.
okay, gotcha. Well, he said 4.
So yeah, if you type in the right parameter for it, it will work. So that easy, if you were on the line with a customer and say, I need more disk, you just do it and say, okay, now do your DF. And boom, immediately, as you said, this appears to be bigger for those folks.
Hmm?
Shrinking, it's the same.
Yeah, as long as you're not making it small.
So that's, there's also the ability to set quotas and stuff like that, and I know the limits and things, but I won't go into that. I'll just give you a taste of the idea of how you do that kind of stuff. Let's take a look at the idea of memory and other resources that you can set for the virtual servers or control for the virtual servers. There's a nice command, VZ memcheck. It gives you an overview of the resources that are currently being used and are committed for a particular virtual server. And this is in percent. So, for example, we're utilizing for each of these servers like 0.48, 0.41%, and they're committed. This is the max that they can have, 2% and 1% for those servers. You can also get the same information in absolute terms, or like in megabytes, with a switch to it. So this gives us that we are currently utilizing 27 megs in 177 and 11 in the 180 server and so on. Now you can look at the exact resources that are being monitored for that system by looking at the proc user bean counters file. User bean counters is the subsystem that OpenVZ adds to the kernel for maintaining and monitoring resources inside containers. So if we look at this, at the top we've got for UID 0, which is the base system, and then coming down for 177, and then down for 180. So these are all the various parameters that it's keeping track of. I found really quickly when I was working with the system that when I would have these strange failures, at first I thought there were some software problems like that, things wouldn't run properly. Then I would come into here into the user bean counters proc listing, and this last column, fail count, really important column. That should always be 0. If the fail count goes up, that means you're exceeding one of these parameters. And what I found, and in fact I'll try and do it right now, is that often if you have strange failures inside virtual servers because you've exceeded one of these limits in here, and that fail count will start going up, and you'll see that. So if we go back in, and just from practice of doing this demonstration a couple times before, I know if I do a certain series of steps, it almost always fails. So we'll try and see if we can make it fail. This is a planned failure.
In this case, it's not broken. It's just doing what you've told it to do. Don't let it exceed these resources.
Right.
So this is an expected behavior, not a failure in some way.
Oh, here we go. Okay, so what I need to do.
right?
Yeah.
It is.
So service just started.
So we started that one. Let's start. This one.
That's already running, I think.
Well, I just installed PHP,
Oh,
and this will cause PHP to run and use up more resources.
gotcha.
Key thing here. And now we'll hopefully get our planned, not really failure, but we want it to fail. I want to see how it works here. Is that MySQL is going to have problems now starting out. Well, I'll just show you this failing, and we'll look at the fail count. The fix for this, you'll see when we go into the proc user bean counters, that there's a particular parameter that's exceeding, and then you can use the VZ control to up that parameter. There's also a really useful program called VZ Split that allows you to create some same base configuration files for creating new virtual servers. So, for example, if you want to divide a particular machine into like 30 virtual machines, you can use VZ Split to create a configuration file that sort of evenly distributes the resources across 30 servers. And you can use that as at least a beginning for creating your own custom configuration file for creating future virtual servers. So notice here that MySQL finally did fail. And notice up here, fail count 1 right here for this particular resource was a problem. And we're running out of time, so I won't actually show you, but what the fix for that, temporarily at least, is to run VZ control up that parameter. And as soon as I do that, MySQL will start like that. And just so any quick questions before we get thrown out of here?
Thank you much.
All right, thank you.